Hello Year 12s and welcome back to Mathematics. In this video we're starting our next topic of sequences and series. So in this first part of this topic we're going to be dealing with a thing called sequences. And so this is on page 5 of the booklet. And so we're going to be talking about sequences. So what is a sequence? A sequence is just a string or of numbers that follow a certain pattern. So the way we write sequences are, for example, you could have a sequence of 1, 2, 3, 4, 5, and so on. And they go on forever and ever and ever and ever. And so here, this was just going to be every single consecutive number. Or you could have every consecutive integer number. Or you could have a sequence like 1, 4, 9, 16, 25, and so on. And so this would be an example of a sequence of squared numbers. And so here, a sequence is just when we have a string of numbers that are going on and on and on and on, and they follow a certain pattern. Now in mathematics, the way that we like to write a sequence is using a bit of notation. And so here what we have is the nth term of a sequence is denoted by t with a little n. So what this tn just tells me is that a small n just tells me what part of the sequence is this term in. So for example, for my first one, I could write this as this sequence. I could rewrite that as tn is equal to n. And so for example, if I wanted the first term in my sequence, t1, that's just going to be 1 because I subbed in 1 into n. And so here, t1 is equal to 1. For example, if I wanted the 100th term in my sequence, that would just be subbing in 100 into n, and that would be 100. And we could do that for other sequences as well. And so for example, this second one, that's just the same as writing tn is equal to n squared. And so my pattern here is I'm squaring whatever number is that term in my pattern. So for example, if I wanted the second term in my pattern, I'd go 2 squared. 2 squared is 4. And so if you have a look at the second term in my pattern, I have 4 there. So let's have a look at an example of when we need to use sequences. So here, for this first example, first find the first 5 terms in the sequence and find a formula for the nth term. So the sequence is defined by the following. So t1, our first term is 1, and in every term after that, tn is equal to n minus 1, tn minus 1. Okay, now this looks a bit confusing, but let's actually let's have a go through the example. So the first 5 terms, A, t1, let's start off with the first term. T1, if you have a look at my definition, T1 by definition is just going to be 1. And so here I'm just going to write T1 is equal to 1. Now T2 is when it starts to get trickier. And so we're going to need to use this formula. Now here, if I just sub in T2 wherever I see n's for T2, so T2 is just going to equal to 2 minus 1 over 2, because in my formula, I'm just subbing in wherever I see n, that 2. And so here, that is timesing by T2 minus 1. So what this part tells me is that I'm just going to have, so 2 minus 1 is over 2 is just a half times t1. So this tn minus 1 just means I'm just taking the previous term. So here, if I have n, and I have n minus 1, I'm just taking the previous term and substituting that in. So here, t2 is just half times t1. Okay, so t1 was at 1, so this gives me t2 is equal to 2. Okay, we're just going to do that for all 5 of my first numbers. So here, T3 is just going to equal to, I'm going to sub in 3 into my formula. 3 minus 1 over 3 times, now T3 minus 1 is just going to be T2. And so for this one, I'm just going to go, okay, 3 minus 1, that's just 2 over 3 times T2, which I got from the previous step, is just a half. And so when I simplify this, the 2's will cancel each other out, and I'm left with 1 over 3. Okay, and we can keep repeating this process. Let's do it for T4. So we want we're on the 4th term now, T4. I substitute wherever I see n in my rule, I'm going to substitute 4. So here I get 4 minus 1 over 4 times T4 minus 1. Okay, 4 minus 1 over 4 is just giving me 3 over 4. And I'm multiplying that with T3. Now T3, oh actually I can do it here. So that's just T3. And from the previous part, I got T3 is equal to 1 over 3. And when I simplify this, I get 1 over 4. Now, if you have a look at all of these numbers and the terms that they correspond to, so here I had T1 is equal to 1, T2 is equal to a half, T3 is equal to a third, T4 is equal to 1/4. Hopefully, some of you are starting to notice there's a pattern here. the pattern is, as you notice, it's just going to be 1 over whatever that term is. And so what I should expect for T5 is 1 over 5. So let's actually use that pattern. So here, let's use this particular pattern as well. So I'm going to get, okay, T5, I'm going to go 5 minus 1 over 5 times T4. That's going to be 4 over 5 times a quarter. And so I get 1 over 5. So T5 is equal to 1 over 5. So we've gone through and found the first 5 terms. So here what we had to do was we just substituted out, wherever we saw n, I just substituted whatever term I'm up to in my sequence. So for part B, if we want to find the formula for the nth term, what we can do is we can just write Tn is just equal to, well, based on this pattern, it's just going to be 1 over the number in my pattern. So for T1, that's just 1 over 1, which is 1, great. T2, that's 1 over 2, which is what we have here. T3 is 1 over 3, which is what I have here. T4 is equal to 1 over 4. T5 is equal to 1 over 5. And so here, if I want to just write a simplified rule for the terms in my sequence, I've just got Tn is equal to 1 over n. Okay, cool. So that's how we can start to deal with some sequences. Let's have a go at another example. Okay. Find whether 1.5 and 96 are members of the sequence Tn is equal to 3 over 32 times 2 to the power n, and if so, what terms are. Now here for this question, we want to see if these two numbers are part of this sequence. So 1.5 and 96 are part of this sequence. So what we're doing, instead of substituting values of n into here, I'm just going to replace Tn with these values and solve to see if it satisfies n. So here, for example, I'm going to write 1.5 is equal to this pattern, this rule for my pattern. And what I want to see is, can I actually find a value for n? And n has to be these, what's it called? N has to be counting numbers. They have to be whole numbers in order for this to work. So here, I'm just going to go and see if I can solve this. So here on my left-hand side, 1.5 is just 3 over 2 is equal to 3 over 32 times 2 to the power n. And if I want to try and solve this, I'm just going to move this n to the other side. So what I would get is, I multiply the other side by 32 over 3, and that's 16. And what we were looking for is a power of n, power of 2, that gives me 16. If you're not sure how to solve for this, we can take log of both sides. And if I take log of both sides, what we can do is I can bring down this n to the front as using my power rule. And so here, n is just equal to log 16 over log 2. And so that will give me, I believe that gives me 4. Now the other way that you can do this is you can just notice, okay, actually, so here we had 2 to the power n is equal to 16. 2 to the power 4 actually gives me 16. And so, yeah, 1.5 is in my pattern. So 1.5 is the fourth term. That's what this tells me. Okay, let's have a check if 96 is also part of the pattern. So 96 is equal to 3 over 32 times 2 to the power n. And so I'm just solving for n again. So here, let's just do that. 2 to the power n is equal to, that should be 1. Is that correct? Hang on, let me just check. Yes, that is correct. Okay. So here, wait, nope, it's not correct. I think I got that wrong. Oh, that's 32 squared. Yeah, there we go. Okay, cool. So we've got 2 to the power n is 32 squared. The way I did that was I went, okay, 96 divided by 3 over 32. It gives me 1024. Okay, now this just, I happen to know that 1024 is just 2 to the power 10. So here, n is equal to 10. So therefore, 96 is the 10th term of the sequence. Okay, so that's these first two. If you want to check if these terms are in your sequence, all you're doing is just substituting these into Tn and just trying to find if there's an integer value of n that works. So there we go. Okay, part B. Find the first term in the sequence which is greater than 10. So what we want to do is we want to find what value of n gives me a number greater than 10. The way I recommend doing this is I'm going to go, okay, I'm going to go 3 over 32 times 2 to the power n is equal to 10. And so that helps me find what value of n I need in order to get 10. Okay. Then from there, I'm just going to start solving this. So I've got 2 to the power n is equal to 320 over 3. And the way that we solve this, like I said earlier in the first example, I just take log of both sides. So I'm going to take log of both sides. So I've got log 2, and because it's the power n, I can take the n to the front using my power rule, log 320 over 3. And so n is equal to log 320 over 3 over log 2. And so this just becomes log 320 over 3 over log 2. Now you could use natural log as well, but I'm just choosing to do log, so that's 6.7 something. Okay, so what this tells me is, in order for me to have a term which is equal to 10, I need the 6.7 term. But as I said earlier, n has to be an integer. And so what I need to do here is I need to go, okay, it can't be 6.7 because that's not a whole number. What I need to do is I need to find the next whole number where it actually gives me a number which is greater than 10. And so I'm just going to round this up. So therefore, I'm going to have the seventh term. So n is equal to 7. Wait, actually, let me write it that way. Seventh term. Now we can check this. We can sub in. We can find t of 7 and check that that is greater than 10. So if you have a look at the rule, I have 3 over 32 times 2 to the power 7. So let's just chuck that in my calculator. So here I've got 3 over 32 times 2 to the power 7. Let's just check that as greater than 10. And that is indeed greater than 10. We've got 12. But if I put in 6, look at this, I have 6, and that's less than 10. And so that's not quite right. And so this is 12, which is greater than 10. Okay, so if I want to find the first term which is greater than 10, all I need to do is just solve for my pattern is equal to 10. That'll give me what term in my pattern is going to be equal to 10, and we just need to look at the next possible one. And so that just means I need to round up to my next whole number. Okay, let's have a look at this next one. A sequence satisfies this pattern. So here the pattern is Tn is equal to a half Tn minus 1 plus Tn plus 1. Now if you ever think about this, this just means that my current term is equal to the term before it. N minus 1 is just the previous term plus the term after it. So this is actually a little bit trickier because in order for us to calculate each term, we need the term before it. That's fine, but I also need the term after it. So that's where it gets a little bit trickier. They've also told me that T1 is equal to 3 and T2 is equal to 7. Now there's a few ways that you can figure out what the next, and we want to find what T3 and T4 are. Now there's a few ways that you can figure out what T3 and T4 are. First of all, you could actually sub in T2, for example. And so if I sub in T2, actually go through this. So if I find T2 using my pattern, if n is equal to 2, then what does that tell me? T2 is equal to, based on my pattern, half T n minus 1, which is just T1 plus T3. And so here I can substitute T1 because I have a value for T1 into here. And I also have a value for T2. I can substitute it into here and I can solve for 3. It's T3. So here I'm going to do that. So I've got 7 is equal to a half times 3 plus T3. And we can solve for T3. So I can multiply by 2 to get rid of that half. And so here, therefore, T3 is equal to 11. Now that's one way that you can do it. Another way that you can do it is if we played around with the equation of my nth term. So here I've got Tn is equal to a half Tn minus 1 plus Tn plus 1. What I can do here is I can just rearrange this, and instead of making this in terms of Tn, I'm going to make this in terms of my latest term, which is actually Tn plus 1. So let's do that. So that is just going to tell me that 2 times Tn is equal to Tn minus 1 plus Tn plus 1. So therefore, Tn plus 1 is equal to 2Tn minus Tn minus 1, just from rearranging. Now these terms here, n plus 1, n and n minus 1, those just tell me what position in my sequence is. So they're just relative positions of each other. So if I was to rewrite this for Tn, actually, we wrote this in terms of Tn plus 1. And so that tells me that in terms of Tn plus 1, that's just Tn, so the term before it, minus 2 times Tn, the term before it, minus Tn minus 1, which is just 2 terms before n plus 1. So I can rewrite this as Tn is equal to 2Tn minus 1 minus Tn minus 2 by just changing the index or the spot where this particular term is. And so if I wanted to find the fourth term, oh, actually, let's just check this with my third term and see if this works. So if I want T3, that's just equal to 2T2 minus T1. So let's just check that is the case. So T2 was 7. So we've got 2 times 7 minus T1, which was 3. And so here, that's 14 minus 3, which is 11, which is exactly what I got for T3. And so this formula is just another way of rewriting the original formula that I had up here. So let's use this formula to find T4. So T4 would be equal to 2 times T3 minus T2. So T3 was equal to 11. So I've got 2 times 11 minus T2 was 7. And so here this is 22 minus 7, which just gives me 15. Okay. So this is another way that we can actually work with our sequences. So we can re-index our sequences, and that helps us to figure out what a particular term is. Okay, so that's how we can work with sequences. So just a quick summary of what we looked at in this video. A sequence is just a series. A sequence is a string of numbers that follow a particular pattern. And in order for us to find a term in a sequence, they will usually give us a pattern. And what we want to do is want to figure out, sub in what term we are looking at. So here the n just tells me what term in my sequence I'm looking at. If we want to check if terms are in a sequence, what we do is we substitute values in. We substitute that term in and see if it satisfies a pattern. And we can also actually work around with different sequences as well. So in our online lesson, we're going to go through a few more examples of this and actually play around with some sequences. But that's it for today's lesson, Year 12s. I'll send you a few questions for you to have a look at in preparation for our online lesson. Bye. Oh, wait, before that. And as always, Year 12s, stay safe, stay healthy, stay wonderful, and I'll see you in our online lesson. Bye.